You've probably studied the slope of a line in an algebra course before and probably saw it written this way. M for the slope equals, is this fraction, y2 minus y1 over x2 minus x1. Now let's look at this more closely because there's a lot of information contained in here and we can look at it different ways. Let's take a picture here. All right, here's a coordinate system, and suppose that we've got a line and we want to measure its steepness. So we pick a point on the line and we'll call that, say, the first x value, and this will be the first y value. And then we maybe move along this line up to some other point. Any other point will do. And maybe this point here, okay, that's a second x value, and this is a second y value. Now we want to measure the steepness. So, if we started at this point, and what if we went way out here and then up a little bit? We would have a line, say, that looks like this, right? If we started here and went way out here like this and then just up a little bit, we might have a line that looks like this, not very steep. Or what if we started here and went out just not very far, but went way up, all right? So maybe we got something that looks like this. So it might be something like where we start here, we go out a certain distance. If we go up a little bit, we get kind of not a steep line. But if we go out that same distance and we go up quite a bit, we have a much steeper line. So what we're doing is comparing the vertical change that we make to the horizontal change. If we make a particular horizontal change and make a small vertical change, we get a line that's not very steep. If we make a particular horizontal change and get a big vertical change, then we have a steep line. And that's what we're doing in this formula. We make a horizontal change, right, from x1 to x2, right? This is the difference between x1 and x2. And then this measures, the numerator measures the vertical change. So I'm going to write this in a different way. I'm going to write it as just what it is. y2 minus y1, that's the vertical change, and x2 minus x1, that's the horizontal change. And I'm going to use this when I want to compute the slope. If I have a picture, I'm going to use this. So this is really useful when you have a picture. That means you have a graph. Now I want to write it another way also that's useful when I'm working with an application. When I have an application, m is going to equal, the slope is going to, m is going to equal the change in the output on top and the change in the input on the bottom. So look at what we have here. Let's come back over here. What is this? This is the difference in the y's. Now the y's, those are the verticals. That's the vertical change. And what does the vertical represent on a graph? That's the output, right? And what about the x's? The x's, well, that's the horizontal change. And what are the horizontals? That's the change in the input. So when you look at a graph like this one over here, you have a horizontal axis. Those are the input values. And you have a vertical axis, which are the output values. So when you're really dealing with just symbols, if I'm just given numbers, right, if I'm just given numbers here, this is good if you're just given numbers. I'll use that formula for computing the slope. If I'm given a picture, I'm going to use this form right here. I'm just going to count. I'll go down to my picture, start here on the left, count over and count up, and just put that in for the fraction. But if I'm given an application, okay, this is what you would want to use in an application. Because in an application, you're dealing with how does the output change as you make a particular change in the input. And where does this formula come from? All right, well, let's look at it here. If you come down here and make a change from x1 to x2, how far is this distance right here? What is that distance? Well, you can get it. What if this was 3 and you went to 10? What is that distance? You start at 3 and go to 10. What's that distance? It's 7. And how'd you get to 7? You did 10 minus 3. So it was this, the right one minus the left one. So in this case, it's what? x2 minus x1. And then what's this vertical distance right here? Well, if this was 5, right? If this was 5 and this was 8, what's that distance here between 5 and 8? It's 3. And how'd you get it? Well, you took the 8 minus 5, or in this case, the top minus the bottom, which is y2 minus y1. And then to make a comparison, we make it by division. We're going to take y2 and divide it by y2 minus y1 divided by x2 minus x1. And there's important information given in the slope. The slope, this is equivalent, right, the same thing as the velocity, or we might even say not necessarily velocity, but how about speed?